So for those of you who have cell phones, it would be great if you extinguish them. Don't just turn them off, but turn them all the way off. We have electromagnetically sensitive people in the audience, and they and I would appreciate it. First of all, thanks everyone for coming out. And the topic of the day is the dark side of smart meters, and primarily to tell you what PG&E doesn't. I am Rob States, briefly 3 MS degrees, not in microwave technology. One would wonder why listen to me. So I tend to list relevant work experiences when I'm giving a talk. For about 2 years, I consulted for Microsource that makes microwave synthesizers up in Santa Rosa. And I was doing, basically circuit troubleshooting for those guys. I've designed several mainstream power generating pieces of equipment in the grid, and I'm the planet's leading expert on pulsed impingement. I sold a job to the Department of Energy, and this technology is capable of reducing the planet's energy consumption by about 0.75%. That's one invention. 0.75% reduction is basically doubles the efficiency of drying of paper. So the point being that I have expertise both in the microwave side and in the power generation side. This is kind of the introduction for the afternoon. So the idea is to basically outline what is a smart meter, and then the health impacts, which are like drive you nuts, and the privacy impact, which will double drive you nuts. And the idea is to create an action plan, which, since I'm an engineer, I don't have the action plan, but we have Larry Bragman here who does have an action plan. So let's describe what we're talking about here, which is the power grid. And during a typical day, there is lots of power consumption during the middle of the day, and there isn't very much in the middle of the night. And so the primary reason for having smart meters is to move some of this demand over to there. So basically, a smart meter is therefore responsible for 0 reduction in usage. 0 reduction. It is primarily a device that moves power from one place to another. Unlike, for example, superconducting high tension lines. Okay, those would be responsible for a 30% increase in total efficiency and a total reduction in usage of power, usage of fuel to generate the power. Boy, am I not doing a good job here. But these meters of themselves are responsible for no reduction in the consumption of electricity. The customer's behavior is responsible, and on a good day, PG&E cites the number 4 to 12%. Okay, so if you think of a typical $100 a month power bill, that's like $40 a year. I mean, how much customer sort of activity are you going to get out of that fairly small amount of money? So that factors into, well, I'll get back to that. This is off of Silver Spring's website that basically describes the system, and as you can see, it's very simple. Any straightforward questions for that? Let me give you the quick tour de force. Over here is your house, and here is a smart meter that's connected to your house, and eventually this smart meter then talks to PG&E, which is over here somewhere. But what it also does is it talks to the neighbor's meter, and that to the neighbor's meter, and that to the neighbor. And what we're showing here is that this is what's called net topology. That means your meter has to send about 700 numbers a day to PG&E so that they know time of day use for your house. Okay, that only takes 45 seconds, but it may not be talking directly to a cell tower. It may be talking, which is this thing right here. It may not be in direct line of sight to a cell tower, so it will talk to its neighboring smart meter. That neighboring smart meter will talk to another neighboring smart meter, and so the duty cycle the PG&E cites is for this meter talking, let's say this meter talking directly to a cell tower. But what they are leaving out of the details are this meter may be collecting data from tens to dozens to hundreds of other meters. In fact, the duty cycle of this thing could be nearly continuous. So it is an unknown factor. Now, I'm in the civil engineering fire life safety business, where we are designing civil engineering structures for safety of individuals. And in those structures, we are overwhelmingly conservative. We make the most severe assumptions to preserve human life. In this system, that says the thing is on most of the time. And that violates some of the major tenets of how these systems have been sold by PG&E and how they have been approved by the FCC. So basically, this baby gives power to your system, to your house, and it sits there and thinks about the power and then sends its thoughts back. Let's say, and this smart meter also has a second channel of communication where it talks directly to what are called smart-enabled appliances inside of your house. And currently there are none or virtually few smart appliances, but the CPUC wants to change that. This is the radiation pattern from a typical smart meter. They have what is called a dipole antenna, and it radiates radially. So if the antenna is like this, it radiates out this way and doesn't radiate very much out this way. And this is required so that it can both talk to a cell tower, which may be slightly above it but at a shallow angle, or to a neighboring smart meter, which would be a lateral communication. But what is in the lateral distance between this meter and the next smart meter? That's people, that's houses. That the majority of the radiation that comes off of this is not for communication. It's wasted radiation that goes to individuals and structures in the general vicinity. Cell phones use this style of antenna exclusively, and part of it goes directly into your head, which is a major concern. If you read the fine print on an iPhone, it says always use the iPhone 5/8 of an inch away from your head. That means you are told in the fine print 6-point type in the sub-paragraph of some appendix to hold the thing with an air gap between your head, because when it is touching your head, this radiation is actually above the FCC limit. This is strictly optional. These antennae could be designed as high-gain transmitters, and all it would mean is you either put it on this side of your head where the cell tower is this way, or this side of your head where the cell tower is that way, and you could drop the energy consumption, or let's say the energy wasted to your head by a factor of 1,000. It would be fairly easy to design. But in 1996, the Telecommunications Act relieved them of any local requirements to get the position of the cell towers approved. So they can put a cell tower anywhere they want. And the rider in 1998 resolved them of any liability. So they are in a position of not requiring to consider your health when they're either designing the system or designing the phones. And more convenience is the sales feature, and that is what's been driving this industry, is more convenience. A smart meter typically goes on the outside of your house, and so there it is located. But what's directly on the other side of this? That's the interior of your house. So because we know that this is a laterally transmitting device, on the other side, this is being laterally transmitted through the wall. So if you're sleeping over here, you're getting radiation from this meter, 8 hours a day. If this is your office, a high occupancy area, the exposure could be substantial. So let's discuss the health ramifications of this piece of equipment. We are fairly familiar with ionizing radiation, which, say, an X-ray hits your cell inside of the cell's nucleus. It breaks a DNA molecule, and from then on, the children of this cell have a defective DNA, which turns on a RAS gene or some other naughty thing, and this cell then replicates and becomes a tumor. So this is a well-known, well-understood action path, but this is like an X-ray or a cosmic ray. It is an extremely high energy piece of radiation, and cell phones and smart meters put out much lower frequencies, typically 900 megahertz. And so we are assured by some scientists that ionizing radiation is required for this. But in fact, non-ionizing radiation disrupts van der Waals bonds, and that is the major bond during creation of proteins and replication of DNA. And you may think of a covalent bond as the rubber on the bottom of your shoe. If you want to get the rubber off, you have to scrape it or you have to cut it. It's very ruggedly bonded to your shoe. But a van der Waals bond is like the mud that's on the bottom of your shoe. It's fairly easy to scrape off. If you rinse it off, it comes off easily. That's a low energy bond. And you have much lower frequencies that can disrupt these. You are producing roughly 3,000 miles of DNA per day. You're making about 20 billion new cells. Each one has got about 3 feet. You figured out it's like 3,000 miles. You're zipping this stuff out like crazy. And every time there's a disruption from RF radiation, you are running the risk of creating an error either in DNA transcription or in the creation of a protein. This fuzzy slide is looking at an individual who is sensitive to microwave radiation. In this case, the person is talking on a 900 megahertz handheld phone. That means it's not even a cell phone. It's a phone that only talks to a base station that's a few feet away, and it's a convenience so that you don't have a wire. This is a normal person, and when they talk on this 900 megahertz phone, there is virtually no change in their physiological condition. But this person, their heart rate goes from roughly 68 up to 122, and the heart rate becomes irregular. And as soon as you turn the phone off, they return to normal sinus rhythm. This is one of many sensitivity issues with microwave radiation. This is a normal person. This is a sensitive person. How many sensitive people are there in a general population? And this Swedish study indicates that there's roughly 3% of the population that is severely sensitive to microwave radiation. And you put smart meters in a residential area, and these people either have to move or they have to heavily shield their houses. 35% of the population is moderately sensitive. So we are in a gray area here where the impact on property values and the impact on the population in general is relatively significant. This is a study done in Spain where directly underneath a cell tower they are mapping out as a function of distance, and this is 300 meters, so that's like 1/8 of a mile, something like that, about 1,000 feet, from close to that far away from a cell tower, the various psychological and physical symptoms that people experience. And right underneath the cell tower, we're looking at 80%, 70+% of the people experience fatigue, drowsiness, headaches, discomfort feelings, depression. So even the existing cell towers are generating significant problems, health problems for people nearby. This is a quick example of what we're dealing with in the case of an industry that's generating $500 billion worth of market revenue a year. This is a Reuters news service, October 13th, 2009, just last year, and they were reporting on a South Korean study that studied the links between mobile phones and tumors. And at 4 o'clock in the afternoon, the Reuters news feed said, high-quality studies often show potential cancer link. Underneath that, the second bullet said, industry-funded studies most likely to show no link. Then you read the data that this study verifies these conclusions. At 6 o'clock, only 2 hours later, these two bullets were compressed into a single bullet and changed to read, it found no significant association between the risk of tumors and overall use of mobile phones, including cellular and portable phones. Basically, a 180-degree change, and as you can see, only 2 hours later, this is the power of the cell phone industry. We see this time and again in the cell phone industry, in the smart meter industry, that we're seeing a lot more industry spin than we are hard science. This is the most complicated slide that I've placed today, and it is the most important. So allow me to dissect this, give you the importance of what this is. Over here is a map of San Francisco. The peninsula is on the bottom, Golden Gate Bridge is on the top, and as you can see, there is a plus. Okay? The middle of that plus is the Sutro Tower. You can see the Sutro Tower up on the top. That thing pumps out the better part of 20 megawatts of radiated energy into the environment. It radiates AM radio, FM radio, and television. From the period 1973 to 1988, it was the primary source of RF radiation to everyone on that peninsula. What's good about that? A, I don't want to live there, but B, it is a fabulous test tube. You know the exact dose based on where people live. There are 123 people in this study, children under the age of 21, that have contracted either leukemia, lymphoma, or glioma, basically the most common cancers of children under the age of 21. And these little stars indicate where they lived. And They are pretty much all over the peninsula. Okay, they are not concentrated underneath the Sutro Tower. They are fairly evenly distributed all over. Okay, and this is a plot of the radiation they received from the Sutro Tower and those children's prevalency compared to the general population of these cancers. And we see that if you're directly under the Sutro Tower, you have an 18-fold chance of getting childhood leukemia. Not 18%, 18-fold. An 18,000% increase in the prevalency of cancer directly underneath the Sutro Tower. As you go away from the Sutro Tower up to the coast, which is 5 kilometers away, you are still at 4 times, a 4-fold increase in the prevalency of childhood leukemia. This gorgeous correlation persists for all 4 of the diseases studied. In other words, this is a disease of RF radiation. There are no other cofactors. It doesn't matter what your genetic background is. It doesn't matter your socioeconomic position. It doesn't matter toxics that you're exposed to. What matters is where you live on the peninsula and the amount of RF radiation that you receive. This is a plot of the RF radiation as you go from the Sutro Tower out. It is denominated in microwatts per square centimeter, which is sort of an industry standard. It's one of the power factor standards. So this is the number directly underneath the Sutro Tower that corresponds to this amplification. And out here at the edge of the peninsula, we are down in this range of, say, 0.1 to 1 microwatts per square centimeter. Okay? As we move over to this side of the plot, I have given you what the radiative power is of a typical smart meter at 1 foot, at 3 feet, at 30 feet, and at 92 feet. And what I'm asserting is I do not want to be this close to a smart meter. That is in this highly accelerated area where I'm increasing, in this case, childhood leukemia, but by implication, it is biologically active for other diseases. This is the only one that was studied in this study, but what it says is this is a canary in the coal mine, and we should stay away from this level of radiation. When you were 3 feet away, you were here, 30 feet away, you were there, but at 92 feet, you are under, this is a logarithmic plot. So I don't know if you're safe, but this is like an area where it might be safe, or at least safer. So I decided to plot these contours in my neighborhood. Here's my house from Google, above. And this is the danger zone. That is a 92-foot radius circle. And my meter is here, and the smart meter is going to radiate my living room. It's going to radiate one of the bedrooms, and this is fairly dangerous. I would point out that this level of radiation is incident on the roofs of the houses in question. Okay? This is attenuated when it goes inside the house where the children spend most of their time. So the actual risk profile is down here somewhere. So when I plot this in my neighborhood, it is actually much worse out here, and this is an accurate portrayal of what conditions are like inside my house. That is, this is an inside the house contour. This is a risk factor. This is where my neighbor's meter is. And likewise, there's a bedroom affected, and this is my second neighbor. This is a daycare center. Their meter is in the playground of the daycare center. Children will be walking within inches of the smart meter. First of all, PG&E has done nothing to ameliorate this. These have been installed down in LA, and they have not informed citizens who have bedrooms that are near the radiation source, nor daycares or other child-populated areas like schools that have excess. And again, this is a much worse exposure contour than is given here, because these risks are inside the house, and these risks are direct radiation through the air, significantly higher. So the first point I'd like to make is the safety of these devices is not at all verified by the data. And if you take a group of lab rats and you give them an L50 dose of a toxin, let's say lead or mercury, that is a dose that kills half of the population. So if you give half of that dose to you get more survivors, okay? But if you take half of the L10 dose for lead and half of the L10 dose for mercury and you give that to the rats, they all die. What I'm making a point is that the risk factors to human beings and to health is not linear. You can't make an assumption of half is twice as good as whatever. And so in the case of this radiation, it is pulsed radiation, meaning that it's on briefly and then it's off. It's on briefly and it's off. And you do not have the ability when there's a continuous, like with the Sutro tower, which is continuous radiation, your body doesn't have a chance to sort of cope with it. Okay? It is on, it is off. And it could be that this form of radiation is vastly more damaging to human health. We don't know. It is totally unknown risk. The FCC says that 600 microwatts per square centimeter is an allowable continuous radiation. 600 microwatts per square centimeter. That is this line on this curve. As we can see, this is vastly in excess of the measured dose level at a 18-fold increase in childhood leukemia. This level has been based on studies done in the mid-1980s. We are much smarter now, and this study was published in 2002, I believe, 2002, which means the PG&E had every opportunity to be aware of this study before they configured their system. They could have put high-gain antennas on and dropped this by a factor of 1,000, and they did not. They could have done transmission of signals on the power wiring. They could have done optical wiring, and they have done none of that. They have taken a technology path that exposes us to, according to this study, significant risk. Here is a typical smart meter that's installed on a wall, and this is a graph that was measured on the pillow of a person who was sleeping on this side. The pillow. This means that person is exposed to radiation 8 hours every night when they are sleeping, and we measured 0.05 microwatts per square centimeter, well above the safety level. In Italy, their smart grid is powered by a system that uses no radiation. It is technologically possible. If you talk to PG&E, they say no, it is not possible. As George alluded to early on, when I found out about the smart meter, I got a message in the mail that said we're about to put one of those babies in, and I pretty much jumped out of my skin. I did some minor research, and I knew right off the bat these things were trouble on a stick. I called to opt out, and they said, you're in a lot of hurt. We're not opting anybody out. And so I started sending emails to my mayor, and I said, we need to have a town council meeting. I want to bring this up. And we agreed that I would give a 15-minute presentation that's a condensed version of this that gives them some of these findings. I'm a registered PE in the state of California. I have the ability to talk about this subject. When the meeting came up, PG&E was on the podium for 45 minutes giving their spin, and I was denied the ability to present this information to them. So what you're seeing is suppressed information. 2 days before that meeting, PG&E, well, unbeknownst to me, the mayor was forwarding all of my emails to her, to PG&E. PG&E requested my presence at a meeting. They gave me the spin. I said, you're way above these leukemia levels. Their spin was, that's only one study. We use the FCC. They look at all studies. We use the standards from the UN. They look at all studies. And they, as we'll hear from Mary Beth later on, there is significant insincerity in how the industry uses this. Just recently, the Los Angeles Unified School District said that 1994 law that gives local governments no control over cell phone towers, they want that repealed. They see this impacting the health of their children. The European Parliament has recently voted in favor of being more precautions to human health than is currently being done. France has banned cell phones in primary schools. They can only text. And the federal government has officially acknowledged that electronic hypersensitivity is a disability. That means the municipalities are on the hook to ameliorate effects of affected people. This, I believe, is the whole reason PG&E came to see me, the privacy issue. Here we have a smart meter that is monitoring the power going to your house, and here are some activities that might be occurring in the house. And what I've shown here is a $3.24 DSP chip. DSP stands for Digital Signal Processing. This is something that I learned at MIT. And for the better part of 9 years, I worked for Ingersoll Rand, and I designed digital signal filtering for industrial control systems. And what I mean by that is when you are putting power to a motor in an industrial process, by looking at the frequency characteristics of that motor, you can determine the health of the process. It's a great way to not have to put a probe inside of the process. All you have to do is watch the motor and infer what the process is doing. If I have a $3 chip inside of this, I can do a wealth of interesting things. For example, when you turn on a hairdryer, that's a series wound motor that has a 1800 watt heater attached to it. The signal for that is totally easy to spot. If I were to look at that in the Fourier transform domain, I could infer that at 5 o'clock in the morning or so, you turned on a dryer for 10 minutes, 8 minutes, 4 minutes, some number. When you turn on the fan in your bathroom, that is a fractional horsepower induction motor with a shaded pole start. Okay, again, fairly easy to spot. And the smart meter could therefore say, gee, at about 6:02 in the morning or 3 in the morning or whenever, you turned on the fan in your bathroom. Or here's a woman enjoying a vibrator. That is a DC motor with a variable speed drive and possibly a switching power supply. Okay, this is easily discernible, okay, from these other appliances. This woman turned it on for 20 minutes at 9 p.m. at night, okay? This meter is fully capable of keeping all of this information in its memory. PG&E hasn't told us whether they're doing this or not, but what they have told us is the software inside of a smart meter is proprietary. That means we don't get to know. Thank you so much. I doubt if that's a coincidence. A.C. Nielsen collaborated with MIT in 1992, and they said, barcodes are great. That tells us what you buy. Customer cards are great. They tell us who bought the stuff. But what they also said was, what is missing in our marketing strategy is when, where, and how usage. And they were presenting this to MIT saying, this is a problem. We do not know when, where, and how our products are being bought, how they're being used. If the smart meter supplies this information, I assert that this has an extraordinary amount of marketing value. This isn't a trivial bit of information that we can discount. There are people with a lot of money who want to know this. And PG&E is asserting, well, we're not doing it. But by the way, all the stuff that goes on inside of the meter is top secret. Here is, and if you think that's bad, they're just getting warmed up. Here is graphics from the industry itself talking about this link inside of the house. Smart meters talk directly to smart-enabled devices. It's like a Bluetooth, okay? And the CPUC has already committed to mandating that all appliances sold in California are smart-enabled, which means they will intelligently talk to your smart meter over what is something like a Bluetooth link. So that means when you're in the, here they are enjoying their smart meter in the entertainment room, it will be telling us devices that are on, what they're doing. Here's mom and daughter in the kitchen. Here they are preparing a healthy snack. And here we have where they're enjoying their smart meter in the bedroom. This is right out of their literature. Bold-faced. They're telling us this is the information that this meter will be privy to, far more detailed information than it is inferring from its own digital signal processing capabilities. We do not have a block diagram of that meter. We don't have the software that's used, and they are only alluding to the data that is being collected. In the meeting that I had with him, they described the data that they were collecting, but they did not allude to the fact that because this is a digital signal processing device, it can infer a great deal more. In addition to that data stream, which is currently uncontrolled. They're not talking about it. There's no law against them taking it based on how they're qualifying these devices legally. And in addition to that gaping hole in security, UC Berkeley professors agree that the security they're using just on the devices as they're currently described by PG&E, the security is insufficient. which means the data that they're collecting is like easy to hack and easy to broadcast to the rest of the world. The Fourth Amendment to the Constitution says, the right of the people to be secure in their persons, houses, and papers shall not be abridged. This thing is directly looking at the interior of your house if it collects this sort of information. This I have not given permission to PG&E to do, as no one in this room has, because they have not even asked for that permission. They are assuming that this meter is identical to the meter that they currently have a utility easement for. Okay? But the current meter, it sits on the side of the house, and I could care less if somebody walks up and looks at the numbers. Go ahead. Look at my neighbors. Have a blast. But I do not want this thing giving a diary of the internal activities in my home to the highest bidder. I'm in a court suit with my health insurance provider saying, listen here, you were supposed to cover my kidney disease. What's wrong? They stand in court and say, Your Honor, look at this information showing that this person was up in the middle of the night for months and months before they ever contracted with us for health insurance. They didn't disclose this to us. They're being ingenuine. And you can imagine the ramifications of this if this is being sold to the highest bidder. The CPUC's charter indicates that they are dedicated to having safe and reliable equipment. I doubt if that is supported by how this, by the preceding. TURN, the Utility Reform Network, agrees when they are basically providing a contrary opinion to the release of the smart meter equipment. I'm not doing too bad. They said that PG&E's business case for the analysis is overly optimistic. Like, you're going to get $40 a year, and you're going to do much for that? That's basically dinner and a movie. The demand response forecast is overly optimistic. They say meter reading could be accomplished with a less comprehensive system. Enough said. The action plan, I don't have one. Clearly, health is a problem. Clearly, privacy is a problem. But health is governed by two federal acts that are fairly onerous. Tobacco was legal for decades before we finally started turning the tide, reducing how much advertising they could do, requiring packaging labeling. We are in the same situation with electromagnetic sensitivity, that it's going to be a good 20 years before the data is in, before it's published in peer-reviewed journals. We've already got data that says there are health impacts, but the level of proof that's required by federal agencies, that's going to take longer to develop. So we're in a case of buyer beware.